Huh? Hello all. This is a test. This is a test message or test video performed to see the live. Hello Manoj or Siddharth. Please let me know like how's the audio quality and everything. Hello Abhay Agarwal. Good evening. So I'm waiting for the other participants to join. Hello Vishu, hello Sheda, hello Shamron. Yeah, let's wait for a few minutes. I'm waiting for people to join. We'll be starting the session in a minute. Hello, Saida, are you able to hear me clearly? Is my voice clear? Before starting the session, I just want to check it. Is my voice clear? Before starting the session, I just want to check it. let me make some corrections. Just a few more minutes. I'll start with the session. Just to verify my voice is clear. Okay, I hope now it should be clear. So let's not delay and let's proceed with the session. So my name is Gowri. I'm a network security consultant working with Byte Information Technology. So I'm here today to take you through a basics, very basic fundamentals of networks. So this lesson would cover you like mostly on what is the mandatory things that you need to know in networks, and what are the devices that you see in networks, and what will be the scope in network when you learn networking. So this is the agenda for the today's course. So let me take the first topic. Let's go jump into the topic. So first we will go to so I wish this session to be an interactive one. So you can post any comments, so I can look at it and reply back to that. And also, I want to know like if you have any idea about networking, you can just post it over the chat. So I wish it to be an interactive session. So it will be very good if it's an interactive session. So I can also make the session very much comfortable. Sure. So let's see. Let me start. So okay, no worries, Yada. I'm just starting from the first. So everyone who has zero knowledge in networking can learn everything about networking. So what is networking? Networking. Basically, networking is interconnection of multiple devices. The devices may include like computer, mobile, or regardless of anything. So you can say it as interconnection of multiple devices regardless of geolocation. So I'll open and show it to you a basic setup of network, like how it is. So you see here, right? So um, this is like a basic setup. You have a computer, you have a printer, you have an IP phone, you have a multiple computers connected to a switch. So this is like a simple network. So which connects multiple devices into a single switch, from which it takes you to the further communications into the geographical environment. So this is the basic network idea, like connecting of multiple network devices with the capability of switch or a router or further stuffs. So I'll before proceeding with the class, I want to show you what are the tools, what are the devices available in network, what are the mandatory devices that you should know about the network. So this is a PC, as you are aware. This is a laptop. We call this as a PC or a laptop or a printer or an IP phone. We call all these devices as an end host. So these devices are called end host or node, or it has two different names. You can call it as end host or you can call it as nodes. So these are two different terminologies for all these devices, and these devices are the common network devices. So first one you see here is a switch. This one is a router. This one is a wireless access point, and this one is a firewall. So these are the very mandatory devices that you should know in networking. So so like you would be working on this devices only, not more than this. There are advanced devices than this, but as a new engineer, you will be knowing this. You should know this. And so, any questions till now? Okay, let's proceed further. So now let's let's see what is I'll take you through the real-time example at the end of the session. Right now I'll walk you through what is computer networks. So computer network. So a computer network which is a computer network, a system in which multiple computers are connected. Like it can be a printer or scanner, or it can be a POS machine or a fax machine. Like you see this topology, right? So this is a computer network where you have the PCs, printers, IP phones, and you can have the scanners. So this comes into the computer networks. So as I said, these end devices are called as host or nodes. You should be aware of this term. So in network environment, people call this as many times you can come across this scenario like nodes or end host. So it is a very common term. You should be very knowing about that. So so this is about the computer networks. Now let's jump into the deeper topic. So computer network is So now let's jump into the very main topic. So types of networks. So once you jump into the types of network, you have two different types actually. So one is the LAN and other one is the WAN. So first we'll see what is LAN. LAN is the local area network. So area network in the sense uh, where multiple devices connected inside an organization. So let me show it to you with an example. Just a second, let me open that file. So let me open up the LAN topology. So you see here, right? So this is called as a LAN topology, where you have an organization inside which you have multiple you have a mechanical department, or you have a civil department. So this entire PCs or this entire machines that are inside an organization, or like this comes under a LAN topology. So any group of computers or nodes or end host that is inside an organization, or inside any unique system, it is considered as a LAN. So you see here an example. Under Anna University, you have mechanical department. In mechanical department, you have like multiple PCs. In civil department, you have multiple PCs. So this entire thing is come under Anna University. So this is considered as a LAN. So when you go to this organization, Wipro is located in Chennai, Bangalore, wherever it is. So this entire network is considered as a entire Wipro network is inside the Wipro network is considered as a LAN. Say for example, if you go to an internet cafe, you have n number of computers in the internet cafe. So that is considered as a LAN. So this is considered as a LAN. So and in your home, you may have a wireless router. In your wireless router, you may connect, or you may connect your phone, you may connect your laptop, you may connect your PC. So all these devices connected to a same network, that is called as LAN, which is local area network. So let me give a description of that. Same network, which is called as LAN. It is called as a local area network. So when it comes to WAN is connecting between organizations. It is a connection between the organizations. The terminology may differ. I'm just giving you an understanding of what is WAN. But if you search it in Google or any browsing station, the terminology may vary. I'm just giving you like the understanding like what is WAN is. So let me open up a WAN topology that I have with me, so you can have understanding on that. So you see here, right? So I have created a scenario where Wipro as an one organization and Infosys as one organization. So the computers or any kind of devices inside it are called as LAN. You see here, right? LAN. Inside Wipro is in Chennai and Philippines, wherever the location, regardless of location, it comes under a single entity of Wipro, so it is considered as a LAN. So this PC can communicate to this PC, any PC can communicate to any PC, regardless of any disruption. But if you want to communicate between Wipro and Infosys, you need a WAN connection. So you need a vendor. So WAN provider may be like an Airtel or BSNL or Vodafone. These are the WAN providers in India. So you have like multiple WAN providers across the globe. So this is the WAN differentiation to communicate between different organizations or to communicate between different domains. You need to have WAN connection. So this is a very basic level of segregation between the LAN and WAN. So just if in case of any queries, just let me know. I'll clarify till now and we'll proceed further. So this is regardless of location, you can connect between countries, organizations, etc. Yeah, I'll tell you what this MAN is. MAN is Metropolitan Area Network. So where MAN is not a major topic over here, but I'll tell you like what is MAN is. So you see here an organization as Wipro, right? So you can have like a group of organizations, say for example Wipro or Infosys or any CTS. So like these like group of organizations which have a separate network connected over it is called as a MAN, which is a metropolitan area network. So I'm saying with Wipro as an example, it is not restricted to any IT organization. It is restricted to any kind of organization. It's like a grouping a small entity. This is the So, Metro, actually, we don't mainly focus on man because your troubleshooting or your level of scope comes under LAN and WAN only. We don't involve much in man, but it is good to know what is man is. So, I hope everyone is clear till now. Any questions? Just post it on comments. I'll help you out. Sure. Let's jump on to the next one. So let's know about the topology of what is the topology of this network is. So so what is a topology? What is a network topology? In what way we connect the network devices. So this is considered. So you can connect the network devices in a pattern. So knowing about that pattern is called as topology. So let me tell you the topology one by one. So point to point. So point to point topologies were like your one single computer is connected to another computer. This is not restricted to a computer. Say for example, you're connecting a Bluetooth between two devices, that is a point to point connection. Any signals from the towers, service provider towers, that is a point to point connection. So this is a point to point topology. So in network we use this kind of topology in various situations, but it is mandatory to know what is point to point. So then we'll switch on to mesh topology. So now let's see mesh topology. So as the name suggests, mesh is connecting multiple devices in an environment. So say for example, this PC has connection to all other PCs. This PC has connection to all other PCs. So all the PCs are interconnected. So it doesn't depend on any other PC. Say for example, if I am cutting this cable, I don't need to worry about this because I can have connection from this PC to this PC and I can access via this. So if any line is broken or anything is happening on the network, so, this is a strong network mesh topology. So you can see mesh topology as a multiple point to point connection. You can see it as a point to point connection over here, point to point connection over here, so point to point connection over here. Mesh topology in real time environment, we don't use it in like lower level architecture. It comes under in your further studies. So you need to know what is a mesh topology is. Mesh topology is connecting of interconnecting of all devices as a mesh formation. So now let's see bus topology. There is a topology named as bus topology. So as the bus topology name suggests. What does a bus do actually? When we board a bus, it takes a straight path from any point. Say for example, you're taking a bus from Erode to Salem. It goes on a forward direction, dropping every passengers at the intermediate intervals. So that is how the bus topology is set up. Let me open up the bus topology so you will have an idea of what bus topology is. There is a single cable and you can see multiple connections at the single cable. Say for example, you have a cable connection in your home. You have a coaxial cable connection where you would have find that the cable would be a single cable, and there would be some repeaters where they would have taken connections from this cable and they would be connecting to your TV. So this is a form of a real-time bus topology. So I connected a bus topology with the network devices. This is a kind of bus topology. This one is a real-time one. You see here, right? A cable. This is a coaxial cable where PCs are connected to it. So this is a real-time bus topology. So let's move on to the next one. So the next topology is the is the ring topology. So this is one is an outdated one, but we still use it in some occasions. So in this topology, the network devices are connected in a ring fashion. Let me open up the ring topology. So you see here, right? This is a part of ring topology. So what happens here is, so all these switches are connected, interconnected. Say I'm going to break this connection. So what happens? There is a connectivity loss from this one to this one. So I'm saying if I am breaking this one. Now what happens? You are entirely isolated between these two networks. So this is a kind of ring topology where it was used in old printers. Like every printers would be connected in a ring fashion, and the sharing would be happening in the ring manner. So this is mostly an outdated one, but in some occasions we tend to connect based on the requirement as ring topology. And let's jump on to the next one, which is the main important thing, star topology. So star topology is the very important one in your network environment. So nowadays, whatever scenario you come across in your college or in your office or anything, the fashion they have connected the device is a star topology. Say this one is a star topology where you see the switches in the center and all the other PCs are located around it. And let me take up to the other one. Say you see here, right? in an unused zone. You see, you can move this as like this. It is in a star fashion. So here, if you see, this is a star topology. So all kind of network devices nowadays are in star topology fashion. So your job role would be like, this is a switch, you need to log into this switch and you need to configure a switch appropriate to this PC. So once you configure that way, the PC will get the internet connectivity and you can browse and go with the more stuff. So this is the very important topology in network environment, and so you should be very much aware of this star topology. You may come across many scenarios where schools, colleges, and everywhere you can see like a series of computers. From a series of computers, a cable will be running into a switch which is mounted on left or right top corner of a room. So this is a star topology. You need to, I mean, you would have seen it, but the that is the basic topology view of a environment in school or college. So this is a star topology. Just have a knowledge on this, because many interviewers may question us that what is a star topology, or what kind of topology fashion now this environment is connected. So this may be a question in your interview. So you need to be very aware of it. And most advantage thing in this topology is, if any ring is broken, say for example I'm deleting this connection, so my entire network won't get affected. So only this PC would get affected. I need to relay a cable to connect. So it is a very convenient form of topology. That is the star topology. And I want to know, like, do you have any questions in this topology till now? Okay, so let me, since we have like quite a lot of noise in my background, I'll I will try to finish up with one more topic, and let's make sure like tomorrow I don't have any noises. So let's go with the last topic for today because of this background noise and stuff. So this is a very important one. TCP, OSI, or OSI, OSI model. So every network engineer should be very much aware of this topic, TCP or OSI model. So what is it, TCP or OSI model? So let me tell you that. So you see here, right? TCP IP conceptual layers, OSI reference model. So this model how a network device or how any kind of operation should be performed on a network environment. Based on this setup only, or every network or devices are capable or designed to perform. So as you see here, OSI reference model. So this one is not actually implemented in real time. So it is a reference model. It defines the standard, like how it should operate. So this one, TCP or IP conceptual model, this one states like this is how they operate, this is how the network operates. So let's go with this OSI reference model one by one. So I wish you should know or you should have this take a screenshot of this model, because which is very important. I will go from top to down approach, where every layers I'm going to explain. So this is the 7 layers of the OSI model. I'm going to explain each layer one by one. Okay. Sure, Topology. I will explain about mesh topology once again after this um, TCP or OSI model. So let me finish with this and mesh topology once again. So first thing, we'll go from bottom to top. I'll let you know what is the physical layer. So you just cross-reference this one alone. Under physical, you can see a PC to PC connector via cable. So I'm going to explain that. So physical layer, as the name suggests, it is a very base layer of a network environment. You all the cables or repeaters, modems, everything comes under this physical layer. So here the data are. So here the data are transmitted as bits, which is zeros and ones. So you should know how this happens. You have a computer which is processing data, and the data is being converted from the computer as zeros and ones, and it is transmitted over the cable. So this is what happens in physical layer. So data is generated, and the generator data is converted into zeros and ones, and it is transmitted over the cable. So this is what it happens from the physical layer. So next we'll jump on to the data link layer. So in data link layer, you need to understand that you see here a switch. So from physical layer to data link layer, the communication is transferred. So bytes, zeros and ones are being transferred to data link layer as a bytes. So this is the main thing. So zeros and ones are converted into bytes, and network interface card that is in your computer converts this into bytes and forwarded that information to your data link layer. What is it exactly in data link layer? You see a switch in data link layer. So it combines all these informations from the computers into all this information from physical layer, it combines into frames. So frames, so that is how the switch operates. Each device operates in its own fashion. So yeah, switch operates as a frames, router network layer operates as a packets. So the transport layer operates as segments. So each layer has its own kind of operation. So switch converts this as frames. So what actually frame has? Frames has MAC address, MAC address, I'm giving a overall idea like what does a frame has. Frame has MAC address, error correction and a data. So let me tell you a simple topology. So you have a switch, you have a feed PC, you have one more PC, and you are making a connection between this PC to switch, and you are making one more connection between this PC to this switch. So you see this PC to this PC connection has been established. So first of all, I need you to know one thing as a main important factor. Each PC or any kind of network devices has IP address and MAC address. So this device has IP address and MAC address as same as this device will have the same different IP address and MAC address. This device will have the IP address and MAC address. Why we need this? Because which operates in MAC address. Say this PC says I want to share some information to this PC, but it doesn't know how to share it. So this PC shares its IP and MAC information to this PC. This PC will check for the other end PC's MAC address and forward it. So let me make it more clear to you. So MAC address for this PC, say like FFFF. MAC address for this PC like this is a dummy variable I'm giving. So in the frames it will contain MAC address of the destination PC, which is AAAA, and source PC FFFF, and some data, any data, any data like FTP or any kind of data. Okay, and error control mechanism. Okay, so what happens is this PC will try to reach this PC. So it doesn't know how to reach it. So it will have destination PC MAC address and source PC's MAC address. So it will forward this information to the switch. Switch will always maintain which PC has which MAC address. So it looks for the MAC address, destination PC MAC address as AAAA, and it will directly forward the frame to AAA. So this is how as switch operates, it looks for the MAC address and forward the packet in a form of MAC address. So this is what actually happens in the data link layer. Switch plays a very vital role in data link layer, and you can see the example of data link layer as switch, hub, etc. So this is an example of data link layer. So I think covering the 7 layer would take more time of today's session. So I would like to just refresh this 2 layer just we saw before and wind up the session for today. And let's have a clear session for tomorrow. Let me revise this 2 layers alone for today, because layer is very important when you become a network engineer. So remember, physical layer operates as bits, zeros and ones, and the operations are performed over the cable. Cable transfers the data from a PC to PC. So from the PC, a cable would be connected to a switch. So from the PC, when a communication happens to a switch, the switch, what it does is it it looks for the MAC address information of the source device, destination device, and it forwards based on the MAC address information. So this is what happens in the data link layer. So this physical layer and data link layer are combinedly called as network interface or network access layer in TCP/IP model. So let's have this session end till this one, because these are very important one, and I want to make sure you don't have any noises in the background. So let's you just have this topic revised for today, and let's connect it back on tomorrow. I want to know, like, if you have any questions till now. Okay, sure. I'll let topology alone to explain the mesh topology. So, in a quick moment, let me wind up with the mesh topology explanation for topology. So, mesh topology. So, this is a point-to-point connectivity between a PC. Say if you consider a mesh topology, this PC would have connectivity to all the PC. So it is a mesh in the sense interconnection between all the devices. So that is what is a mesh topology is. So the advantages of mesh topology is, like, if I face any problems in the connectivity between this any particular node, there is another way of communication that can happen in the mesh topology. That is a very big advantages of mesh topology. So it is not widely used in a local LAN area network. It is used in a WAN area network in a protocol level, on a routing level. So you will come to know that in the future. So yeah, that's the that's the thing. And yeah, any further questions on mesh topology or anything? Vishnu. Yeah, I will explain the TCP and OSI explanation at the end of the layers, after explaining the 7 layers. So you will be very much clear once you are done with these 7 layers. Okay students, if I missed any queries for today, we'll connect back tomorrow and you can have the queries. Just refresh the session what we went through, so you'll be aware and you'll be updated. So let's connect back tomorrow. Have a great evening.